Okay. So, like I said, for those of you that are at home, make sure you grab these notes. The homework is a part of the notes as well. So within that packet is your homework problems for tonight. So those of you that are at home, make sure you access that. Those of you that are here, make sure you hold on to that packet. Looks like this. We are in section 6.3. We're doing day 1, and we're talking about graphing the square root function. All right. So what we're going to do over the course of today is take a look at the square root function and then some transformations of this original function as well. Prior to this, we've graphed lines. You might have done that in this class, but in a previous math class, we've graphed quadratic equations, right? We've seen some parabolas and things like that. And we talked about some different properties of those functions. Now we're going to get into the square root function, all right? And there's some things that we kind of want to understand and talk about some characteristics to kind of help us gauge what the shape of this graph is going to be. So one thing that we discussed on in class or earlier on in class is that if we have a negative under our square root, what kind of numbers are we dealing with when there's a negative under our square root? Remember, to simplify those negatives, we had to take out an I. What did that I stand for? Imaginary. Good. So when we had a negative under our square root, we had what was called an imaginary number. And one thing that we discussed in class is that imaginary numbers kind of exist in their own plane, right? Their own complex number plane. Well, when we're graphing all of our different, lines, parabolas, whatever it may be, we're graphing in the standard XY plane, all of our real numbers. So because of that, we don't want to include negatives under our square root. When we choose our X values, we want to make sure that when we plug those into our square root function, it's always going to be positive underneath, okay? And we'll talk about strategy and picking certain numbers got to help us out, so we're doing, less work than we need to. But just so we're all aware, we don't want any negatives under our square root, all right? Let's see how that affects the graph. What we're going to do right now is graph the square root function, all right? We're just going to choose a couple X values to plug in, notice the shape of it, and then see some kind of characteristics based off of that first fact, all right? If I plug in 0 into my original equation, and just so we're all aware, we might not always plug these X values in. It kind of depends on the situation. But for now, I'm going to plug these X values in. The reason for that is this note right here. When we're graphing the square root, it's easy to plug in values that are going to give us a perfect square, right? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. 9, 3, 25, and 5, 36, and 6, right? We're going to try and get those perfect squares underneath our square root each time. So we're only dealing with whole numbers rather than decimals and fractions and all that stuff. Okay. So for this particular situation, we're going to choose to plug in some perfect square values. If I plug in 0, I'm doing the square root of 0, which is what? 0. If I plug in 1, square root of 1 is square root of 4. Square root of 9.
3.
Awesome. Good stuff. So I plug in these values for X. These are the Y values that I'm getting out in return. Okay. So right now I have coordinates. I'm going to use these coordinates to draw the shape of my graph. So there's a point at 0, 0. There's a point at 1, 1. There's a point at 4, 2, and a point at 9, 3. When you're going through and doing this on your own, I would suggest doing about 3 or 4 points to kind of understand what the shape of your graph is going to look like, although it should be the same for this particular function most of the time. When I go through and draw, that's what my graph looks like, okay? Any questions about what we've done so far? So this is our standard function for the square root, all right? This is what the y equals square root of x is always going to look like. Any questions about what we've done so far? Okay. Well, what do we notice about the x and y values of this particular function? What quadrant are all of my points in? What's that? Quadrant 1. And what do I know about the X and Y values in quadrant one? What are they always?
Positive.
Good. So let's relate that back to the first characteristic we talked about with this function, right? We don't want any negative numbers under our square roots. So we didn't choose any negative X values. Notice that there's no point on the negative X axis because of that, okay? If you don't plug in a negative X, chances are you're not going to get a negative Y. So notice that there's no Y values that are negative for this function either, okay? Part of what we're doing today is kind of recognizing patterns, seeing transformations, understanding different characteristics of this function. And one thing that I want us to do is kind of keep referencing this original graph, because what we're going to do now is kind of look at what happens when we add something inside my square root. What happens when I subtract something on the outside? How does that change my graph? So we're going to keep referencing this and make sure we understand what this original function looks like and how it compares to what we're going to keep doing. Okay? Any questions so far before we move on? Everybody good? Okay. So a couple points there on the second page. First bullet kind of just talks about what I said there. So notice that there's no X negative values. Notice that there's no negative Y values. That's because of the domain and range of our function, right? We can't have any negatives under our square root. Otherwise, we're dealing with imaginary numbers. Now, one thing that's important to kind of keep in mind, I said it earlier, we might not always plug in those same X values, and our graph might not always look that way, right? This is when we start to talk about what's called transformations, okay? That's when we're going to compare what we do with our new function to what we did with our original function, see how we kind of move about our XY plane, all right? So what I want to do now is graph y equals square root of X minus 2. So notice now the difference is I'm subtracting something under my square root rather than just having X by itself. All right. Our table is kind of already filled out for us. I'm plugging in 2, 3, 6, and 11. So we see the obvious difference in the numbers that we're plugging in. The reason for that, again, I'm choosing X values that are going to give me a perfect square under my square root. So if I plug in 2, I'll have square root of, so we need to, I'm just going to show this off to the side, of square root of 2 minus 2, which is the square root of 0. And what's the square root of 0?
0.
Good. When I plug in 3, I have square root of 3 minus 2, which is going to give me what? 1. And what's the square root of 1?
1.
1. So we need to be a little strategic in the numbers that we choose, because not every time or is it going to be 0, 1, 4, 9, right? I'm trying to get that perfect square. 6 minus 2 is going to give me what? What's square root of 4? 2. 11 minus 2 gives me 9, square root of 9, 3. Okay. Notice that my Y values haven't changed, but my X values changed. Okay. Keep that in mind for how we see it, the way that this graph looks in comparison to the original function. I have coordinates again. I'm going to go through and plot those. So I'm at the point 2, 0. I'm at the point 3, 1, 6, 2, 11. It's not necessarily on our plane, but we can just move that over there. 11, 3. And this is the graph of this function, square root of X minus 2. If we take a look at the original function, well, first off, any questions, excuse me, any questions up until this point about how I got those values there or my graph? Before I move on. How does this graph compare to the original function? So this is my original square root function on page 1. This is my new function on page 2, and I had the square root of X minus 2. How is it shifted? So they have the same shape, but maybe think about where they start. Jake? Good. Move to the right 2 spaces. Okay. And it says it there, at the bottom of the page. So that's good. The function moved to the right 2 spaces. All right. So keep that in mind for later when we start to kind of build a key for us to understand, well, what happens when I add under my square root? What happens when I subtract? What happens when I add or subtract on the outside of my square root? All right. I added 2 places. I moved to the right, or I subtracted, excuse me, 2, and I moved to the right 2. All right. Let's take a look at another example. Y equals the square root of x plus 3. What value should I plug in for x here? If I want to include perfect squares, what do you think I should do? Okay. -3, right? Because that's going to give me the square root of 0. Right? If I plug in -3, I'll have square root -3 plus 3, which is the square root of 0. And the square root of 0 gives me 0.
I have a question.
Sure. What's up?
Where'd you get -3 from? Because there's like, I'm trying to figure out how'd you got that.
So why I picked -3 to plug in?
Yeah, like how'd you even, like, did you just come up with that, or it's,
Yeah,
no?
so I'm choosing, so look at this note right here. I'm choosing x values that are going to give me a perfect square. All right. So in this first example, I chose to plug in 2 because 2 minus 2 gives me 0. I know the square root of 0 is going to give me 0. I chose to plug in 3 because 3 minus 2 gives me 1. Square root of 1 is 1. I'm choosing values that are going to give me a perfect square. So if I do the same thing in this example, how do I get from, what do I have to add to 3 to give me 0? Well, -3 plus 0 gives me 0. Square root of 0 is 0. I'm trying to get those perfect squares. Okay.
Okay, that makes sense.
So I'm choosing x values like the next one. I'm choosing an x value that's going to get me to square root of 1. Well, what should I add to 3 to get to square root of 1? -2, right? So -2 plus 3 gives me the square root of 1. And then the square root of 1 is 1. Right? So I'm trying to be strategic about the x values that I plug in. And not every time will that graph, or excuse me, the table be given to you with those x values included. All right. What's my next perfect square? Well, I have to plug in 1, right? Because it gets me to square root of 4. And the square root of 4 is 2. What's the next value that I should plug in? 6, because that gets me to what? Square root of what number? 9. The square root of 9 is 3. So for right now, when we're making shifts in this direction, it will be. It's good that you recognize that pattern, that 0, 1, 2, and 3. But when we start to make shifts in the other direction, it'll change our y values. All right, so really good point. We'll see that in a second.
Mr. Sackhouse, can you go over why you chose those numbers?
Sure.
The ones for like the I or X.
Right. So again, I want this to be a perfect square. So here are my perfect squares. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. 25 is 5. 36 is 6. So I want to get whole number values for my y, right? I don't want to have to deal with fractions and decimals. It's not easier for me to do that. Okay. Does that make sense so far?
Yeah.
Okay. So in order to get to these perfect squares, I have to choose x values that will leave me with these numbers inside my square root, right? So I have x plus 3. I have to choose an x value for my first number that's going to get me to 0 because that's just easier to work with. So I asked myself, well, what number plus 3 is going to get me to 0? That's why I chose -3. -3 plus 3 gives me 0. I know the square root of 0 is 0. That's an easy number to work with. If I choose -2, -2 plus 3 gives me +1. Square root of +1 is 1. That's another easy coordinate to work with. And I'm going to keep doing that until I get all of these perfect squares underneath my square root. So what number plus 3 is going to get me to 4? 1. What number plus 3 is going to get me to 9? 6. Right? So you're being strategic about the values that you're choosing. Does that clear that up?
Yeah.
So let me ask you a question. What number should I add to 3 to get me to 25?
2.
To get to 25? So pretty much what number plus 3 gives me 25?
22.
22. Because then 22 plus 3 gives me square root of 25. Square root of 25 is 5. Okay. You also have square root of 16 in there, but it's all the same thing. Okay. Any other questions about that before we move on? It's a really useful skill for us to understand now because it's going to make all of our problems a lot easier. Okay, let's go through and plot these points. So -3, I'm at 0. -2, I'm at 1. 1, I'm up at 2. 6, I'm up at 3. And now my function looks like this. So the square root of x plus 3, I have this shape graph. You just toss it. How does this compare to the original one, Jake? Moves to the left 3 spaces. Good. I should probably stop including things in my notes, right? So I moved to the left 3 spaces compared to my original function, right? If I take a look at the square root function back on page 1, when I add 3 under my square root, I move to the left. All right. Well, one thing that's included here in the notes, notice that we did kind of the opposite of whatever our sign told us, right? The first example, I subtracted 2 and I moved to the right 2. This example, I added 3, I moved to the left 3. All right. So anything, hopefully you're used to my notes by now, anything that's kind of starred, bolded, highlighted, underlined, whatever it is something that we really need to pay attention to. When there is addition underneath the square root, all right, because we're going to see how this changes when it's outside. We move to the left that many places. So when we're adding, we move to the left that many places. When we're subtracting underneath the square root, we move to the right that many places. And we call this a horizontal shift, and it's going to always be opposite of the sign that's underneath the radical, okay? A lot of times we associate right with positive and moving to the right, left with negative, moving to the left. But in this case, it is the opposite when we are underneath our square root, okay? Are there any questions about that point? We will revisit that, but I just want to make sure we're all on the same page before we move on. Everybody good? Any questions at all? Okay. Let's take a look now at an example where we have addition or subtraction on the outside of my square root, okay? Now what we can do with our x values when we plug them in, notice that there's nothing going on inside my square root. I can just choose those values that are going to give me perfect squares, right? So I can have 0, 1, 4, and 9, right? Because there's nothing else going on inside my radical. The only thing that's taking place is on the outside. So when I first simplify, I'm going to simplify the radical and then do any addition or subtraction, okay? Well, for this first example, I'm going to do y equals square root of 0, and then I'm going to add 4 to that. Well, what's the square root of 0? And what's 0 plus 4? That's what gives me the 4. If I plug in 1, square root of 1 is what? 1. 1 plus 4 gives me 5. If I plug in 4, what's the square root of 4? 2. 2 plus 4, 6. And then 9 gives me what? Square root of 9? 3 plus 4, 7. Okay. So now comparative to when I had addition and subtraction underneath my square root and I had to be a little bit more strategic, here I just have to choose what's going to give me that perfect square. So I can go back to this list of values here and just plug these in to start my problems, all right? If those values aren't given to me already, but most of the time they won't be. Any questions about how I got these points over here, these values? Okay. Let's go through and plot them. So I'm at 0, 4, 1, 5, 4, 6, and 9, 7. And now this is what my graph looks like. Any questions about how I drew that graph? Give everybody a second to catch up here. How does this graph compare to the original function, Jake? What's that? No, it's not on the paper, so you have to look. Because up 4, right? Take a look at the original graph on the first page. I started the point 0, 0, right? It's always going to have that same shape for the most part. But then this graph starts at 0, 4. So all of my points from the original point that they were already at are up 4 units. Okay. Any questions about that? So now we're adding on the outside, it's moving up that many units. Okay. The note's on the other page this time. So notice when we add something on the outside now, comparative to when we add on the inside, it shifts it up. So now I have a vertical shift in comparison to a horizontal shift. Okay. What do you think is going to happen when we subtract something on the outside? Is it going to move it up or is it going to move it down? Right? Good. Nice. Let's take a look at this example then. What value should I plug in for X? Does it matter? No. Well, what values do I want to plug in? 0, 1, 4, and 9, right? Because I'm using those perfect squares. Okay. There's nothing going on inside my square root. So I just want to pick values that will give me a perfect square. Give me 1 second here. Yes, I did. Yeah. I don't have to even put this up there, but I'm sure you'll be back. All right. So I'm choosing 0, 1, 4, or 9 because they're going to give me perfect squares. When I plug in 0, I'll have y equals square root of 0 minus 5. What's the square root of 0? 0. 0 minus 5. What's that going to give me? -5. Good. Square root of 1. 1. And 1 minus 5. -4. Square root of 4. 2. What's 2 minus 5? -3. Square root of 9. Square root of 9. 3. What's 3 minus 5? -2. So Emma, going back to your point from earlier, notice that when we're having a horizontal shift, like we're moving to the left and right, all my y values were the same. When I'm moving up or down, all my x values are the same. Okay. So that's just another thing to kind of keep in mind. So now I'm going to go through and plot my points. And our assumption was that when we're subtracting on the outside, we're going to move down. Let's see if our assumption is correct. Well, I have the point 0, -5, 1, -4, 4, -3, 9, -2. So our assumption and the note that's completely blatant on the page is correct. That when we subtract something on the outside of our square root, the graph shifts down. All right. Any questions about that example, how I found these values, how I graphed it, anything at all? Okay. So let's look at this note down here at the bottom again, something that's kind of highlighted, underlined, everything that we need to do. When there's addition on the outside of my square root, you move up that many spaces or that many points. When there's subtraction, you move down that many points. We call this a vertical shift, and that goes with the same sign that is on the outside of the radical. So if I'm adding, I go up, subtracting, I go down. Remember with horizontal, it was the opposite, okay? So what I want us to do right now, just to kind of wrap up, is to create just a little key for us to understand what's going on with horizontal shifts, what's going on with vertical shifts, okay? So let's write this down here. Let's call this our key. And the first thing I want to look at is those horizontal shifts. If I have x, some variable, plus c, all right? And c in this term just means constant. So we're adding or subtracting a number to that variable, all right? So if I have the square root of x plus c, where is my graph shifting? To the left, that many places, right? So we say it shifts to the left. Okay. I have addition under my square root. I move to the left. What happens when I'm subtracting? So if I have x minus c, shifts to the right. That many places. So if it's x minus 4, I move every point from my original function to the right 4. Okay. If it's x plus 3, I move everything to the left 3 from my original function. And these two situations, when I'm adding or subtracting underneath my square root, these are our horizontal shifts. Okay. Any questions so far? Or any questions about anything we've covered up to this point? Okay. Now, if I have just the square root of a number, so that variable x, and I'm adding that c on the outside, how does that shift my graph? Up. Square root of x, and I'm subtracting a number from that. How does that shift it? What's that? Down, right? I'm adding on the outside, my graph goes up. I'm subtracting on the outside, my graph goes down. These shifts are our vertical shifts. All right, and one thing that we noticed here in class, when we're doing the horizontal shifts, our y value shouldn't really change, okay? And our vertical shifts, our x value shouldn't change. What we plug into that function could be the perfect squares, right? Whereas when we're doing the horizontals, we need to be a little bit more strategic. Any questions about this key? Anything that we covered today, just understanding the square root function and some transformations off of that. Because when we come in tomorrow, we're going to add a layer on top of this where maybe we're stretching or compressing our graph and we have multiple transformations going on. Right now, we just want to understand the basics of these transformations. Are there any questions? Okay. Your homework for tonight is in this packet. So for over the weekend, your homework is 4 questions. It's just a variety of transformations. So whether you're adding or subtracting inside your square root or outside your square root. Still have a few minutes here to probably get that started, maybe get one of those done. All right, but for those of you that are at home, like I said, make sure that you access this packet because your homework is in it for tonight. All right. When you come into class on Monday, we're going to go over that assignment, and then we are going to continue on with transformations. One thing I do want to add for for tonight at least, you do have this extra credit opportunity here still, right? 15 points towards your grade. So I would take advantage of that, right? It's a pretty decent chunk to help you boost your grade. And then looking ahead to next week, when we finish section 6.3, the rest of the week, Tuesday, Wednesday, Thursday, we're going to be reviewing because we are going to take a quiz next Friday. All right. And that's going to be on those first 3 sections of chapter 6. Sound good? One thing to take into account is that that quiz is going to be in marking period 4 rather than marking period 3. Okay, so your grades pretty much for this week are the last things that are going to be in this marking period, along with this extra credit if you choose to take advantage of that opportunity. Okay. Are there any questions for me about the assignment for over the weekend or anything related to what we did in class today? Everybody good? Okay.